H1 is about uniform electric fields. Electric field strength is defined as the force per unit positive charge on a small test charge. So if I place a small positive charge into an electric field, it will feel a force, and the force will be in the direction of the electric field. And the larger the field strength, the larger that electric force. We call it an electrostatic force. Placing a negative charge in an electric field, the charge will feel a force in the opposite direction. So field strength is measured in newtons per coulomb. A uniform electric field is a region where the field strength is the same magnitude and in the same direction throughout that region. That's usually indicated with arrows, where the direction of the arrow indicates the direction of the electric field strength, and the closer together the arrows get, the greater the magnitude of the electric field strength. This region is uniform because the arrows are all pointing in the same direction and are equally spaced. We can produce a region of uniform electric field strength by having two metal plates and connecting one to a positive terminal and one to a negative terminal of a power supply. Or indeed we could have one to a positive terminal and the other one grounded, so that it's at zero potential. Or I suppose we could have one at a negative potential and the other one grounded, as long as there's a potential difference between these two plates. For simplicity, let's have this one grounded. So we have a potential difference between these two plates. The two metal plates have a spacing d, and v is the potential difference across them. Now this equation here, the field strength equals v over d, only works for uniform fields. If field strength is to be in newtons per coulomb, then the potential difference between the plates has to be in volts, and the distance between them has to be measured in meters. Now that is all that you need to know to answer the questions in H1. However, I think it's worth looking at what we mean by potential difference just one more time. So if I have two metal plates, and there's a potential on each that is different, there is a potential difference. In the simplest example, one plate may be held at 0 volts potential, maybe it's grounded, and the other plate would be at some positive voltage, so that there is a potential difference of 4 volts between the two plates. But in this example, I've put the bottom plate at a negative voltage. Now the potential difference between these two plates is 6 volts. And the potential difference between these two plates is 2 volts. And you'll notice the arrows are pointing down, pointing away from the 0 volt plate and towards the negative 2 volt plate. They would always go from the more positive to the more negative terminals. So in this final picture, we can see that both plates are negative, but there is a potential difference across them of 2 volts. And the electric field strength is showing arrows moving towards the most negative of the plates. A positive test charge placed into this field will experience a force downwards in this diagram, away from the negative 2 volt plate and towards the negative 4 volt plate.